we are looking at another special kind of system of equations today. We're going to be looking at a two-equation system where one of the equations is linear and the other one is quadratic. So we can do this both graphically and algebraically. First, we're going to take a look at graphically. And on this first example, I am given my graph already, which is super convenient. And I also do have my two equations. So what I can look at is the points where these two graphs, my parabola and my linear line, intersect. Well, that looks like about right here at the point 2, 2, and over here at the point 4, 6. Now what I want to do is make sure I've read my graph correctly. And so what I'm going to do to verify this is plug in the x and y values into both equations and see if they check out. So let's do 2, 2 first. I'm going to plug in 2 for x and 2 for y into my linear equation. And that one works. Now I'm going to plug 2 in for x and 2 in for y into my quadratic equation. And that one does also work out. So 2, 2 is, in fact, one of my solutions. Now I'm going to check 4, 6. So I'm going to plug in 4 for x and 6 for y. And it checks out for my linear. Now let's check my quadratic. And that also works out for my quadratic, so these are indeed my two correct solutions. Now, what if in the event I'm not already given the graph, I'm just given my two equations? We are going to have to graph them in order to find the two intersections. So I'm going to go ahead and graph my linear graph first. This is already in slope-intercept form, so I know I'm going to be starting at -2, and my slope is -3. So I'm going to be going down 3 over 1. Connect my dots. And there's my linear graph. Now for my quadratic, my parabola, one point I know I can graph off the top of my head is just based on our knowledge of transformations. This parent function was moved to the left 2 and down 14. So now I'm going to have a vertex down here at -2, -14. But as far as going beyond that, I am going to need to find some other values. So let's make an XY table. And I'm just going to pick some inputs and find the output. Let's do 2. 2 plus 2 is 4. 4 squared is 16. 16 minus 14 is 2. -6. -6 plus 2 is 4. 4 squared is 16. 16 minus 14 is also 2. I can do 1. 1 plus 2 is 3. 3 squared is 9. 9 minus 14 is -5. Let's do -4 just for fun. -4 plus 2 is -2. -2 squared is 4. 4 minus 14 is -10. And I'm going to go ahead and do -8. -8 plus 2 is -6. -6 squared is 36. 36 minus 14 is 22. So I have a couple points to plot. If these don't result in my solution, I could easily find more just by plugging in more x's. Okay, so I've got 2, 2, -6, 2, 1, -5. Ooh, that looks like it's on my other graph. So I'm going to write that one down to confirm later. -4, -10. And then I had -8, 22. Oh, that one also looks like a point that's on my linear graph. So I'm going to draw my parabola. And I found what I believe to be my 2 points of intersection. Now I know for sure these are points on my parabola because I found them in the XY table. So what I just need to confirm now is that they're on my linear graph. And if they are, then those are my 2 solutions. So let's do 1, -5 first. I'm going to plug in 1 for x and -5 for y into my linear. And that one does check out. So 1, -5 is one of my solutions. Now I'm going to plug in 22 for y and -3 for x to confirm my other solution. And that is indeed my second solution. So I've got -8, 2 and 1, -5. So this is how we solve graphically. Lastly, we're going to do one problem where we're solving algebraically. So again, you could graph this as well, the same way we did on that front page. But if we were going to solve it by hand without using the graph, we need to be able to do that as well. So I've got my quadratic and my linear. And what I'm going to do first is rewrite my linear in slope-intercept form, meaning I'm going to get y by itself. Okay, so there it is, y equals 2x minus 18. And so now what I have is a y equals and a y equals. So what I can do is set those two equations equal to each other and solve. So I'm going to have to expand this out. Remember, x plus 1 squared, that really means x plus 1 times x plus 1. I'm foiling. So that's going to be x squared plus 2x plus 1. Then I can distribute the 2. And then I can combine my like terms. And what this is looking like now is a quadratic equation, which I want to try to solve by factoring. So I'm going to get everything on the same side. I'm going to move over the 2x and the 18, combine my like terms, and that cancels as well. So what I'm left with is not a trinomial, but it's a binomial, and so I'm not going to be able to do my normal x method, double parentheses, but I can take out the greatest common factor. Between my coefficients, that is 2, and then the smallest x I have is x to the first. So I can factor that out of both parts, and that will leave me with x plus 1. So to find my two values of x, I'm going to set 2x equal to 0 and x plus 1 equal to 0. So my x's are 0 and -1. Now, if you recall from the front page, both of our solutions were xy pairs. They were coordinates. So what I need to find is the y that goes with x being 0 and x being -1. I can do this by plugging that x into either of these equations. I'm going to plug it into the linear one because I think it'll be a little bit less work. So when x equals 0, y is 2 times 0 minus 18. So one of my solutions is 0, -18. My second solution, when x is -1, y is -20. So my other solution, -1, -20. So all of your answer solutions for these system problems are going to be ordered pairs x, y in your parentheses.